Hey, good afternoon. Just going to give folks about 1 minute to join and then we'll get started. All right, go ahead and get started. Today we're going to cover system and communications protection. You guys know me. No updates to any of the CMMC information as far as important updates. They have been meeting about once a month through webinars just to provide updates, but the updates have been more about, hey, here's an organization that's gone through the assessment. Here's some of what they experienced, whether good, bad, easy, difficult. Nothing as far as changes to the program, expectations, et cetera, just giving you kind of a firsthand knowledge of what are they experiencing and what it would look like for you to do the same thing. This section, the system and communications protection, it has a lot of NIST special publications and attachments to go through. I consider this one, honestly, one of the more challenging families of controls to deal with for two reasons. One, you can see there's just quite a bit of additional information that you have to reference to make sure that you're meeting the requirements and the intent and expectation of the controls. But the other thing is, as you go through NIST Special Pub 800-171-2, there's very little information about the specifics of what's expected of you. Some of the controls have half a page of information, and you say, well, I get a clear understanding of what they want out of me. Whereas in these controls, a lot of them are a tiny paragraph, and they're almost saying the exact same thing that they said as the title. So I would definitely say that given the complexity and difficulty, if you're going to be going through a third-party assessment, the last thing you want is the auditor to come in and see these controls from a different perspective than you saw them when you were implementing them. So if there's any doubt whatsoever, I would highly recommend working with a third party to get that clarity and to say, what will the auditor be looking for, and have them tell you whether or not they feel what you've done is sufficient. Okay, there's going to be two slides here just to show you all of the controls because there are so many. So again, we won't read these to you because we're going to go individually, but you can see there are 16 controls. That's a lot of slides, so we're going to move kind of quick today. And again, there's going to be a smaller amount of information on each slide because of the sheer lack of information that's in 171. And I'll try to point out some places where you can reference other guides, and you should reference them, as well as some of the pitfalls. So looking at monitoring, controlling, and protecting communications. This one's fairly straightforward. I'd say the couple at the beginning are a little more straightforward than others. And it's really about implementing technologies like firewalls, gateways, routed encrypted tunnels, lots of different options depending on the physical or virtual setup of your organization. But there is an expectation that you have those devices there and that they are serving in a security role, not simply in a networking aspect of just forwarding data through them. Looking at restricting external web communication traffic. A lot of times in the networking space, we say, like, we want anything that's going to communicate out from the network to be returning communication. So it was initiated from someone outside and you're returning a response. Anytime you see internal devices initiating conversations out, that's likely a bad thing. Restricting external traffic that appears to be spoofing internal addresses. You don't want anyone pretending to be you from outside of your network. A big one being considering separate or dedicated communication lines. Remember that when you go through most ISPs and you're going through, say, a business internet connection, a home internet connection, whatever the case may be, you're sharing that pipe with other people and other businesses. You can pay for dedicated lines where your traffic is segmented on a different line or logically segmented, even though you might be riding the same fiber connection. But that way there's no cross traffic, there's no sharing of data, there's no chance things are going to, packets are going to be sniffed, that kind of thing. It does come at an additional cost, obviously, but for a lot of organizations, that's just something that needs to be done. And then you'll see this on a lot of slides. This section, more than any referenced other guides. So I want to make sure that I put which guides you should reference so that you don't have to go back and look through 171 for this information. So you'll see, for example, 841 on the policies and guidance for firewalls, 800 125B for virtualization support. That one's going to come up probably 3, 4, maybe even 5 times. Employing the architectural designs and software development techniques, system engineering principles to promote security. Pretty broad general statement here, but applying security engineering principles to new development systems or those undergoing major upgrades. So it's very similar to the system design lifecycle, even the software design lifecycle, development lifecycle, excuse me, where you're not putting in a new system or upgrading a system without considering security and putting in the security principles right from the start. If you're undergoing a major upgrade, that's a great time to go ahead and say, is it the status quo? I'm lift and shifting to the next version of something, or do I need to reconsider my security architecture? If it's a brand new system, that should be an obvious, because you really shouldn't be able to develop or implement a system that hasn't gone through security gate reviews. Whether you're talking about physical, virtual, whatever, layered defense, you want to have that layered defense or defense in depth approach or principle. So let's not rely on a single technology, service, access rule, whatever the case may be, to prevent an attack. You've got the ability, especially with modern technology, where you can have multiple modules or features within the same vendor's product suite. So you might buy one appliance and then have 5, 6, 7 different ways that you can layer that defense in. Make sure that you are incorporating security into the system development lifecycle. As I mentioned earlier, this is a process change for the organization and the business. Making sure that security has buy-in at the beginning and as a stakeholder is helping develop not only the solution, but the project plan, the budget, things of that nature. If you're brought in after the fact and folks have already decided who the stakeholders were, what their budget would be, and their timeline for delivery, your ability to influence any of those is almost nothing. Delineate between physical and logical boundaries. Again, a lot of times this is going to come down to cost, the same way we talked about the internet connection. The smaller the organization, the more difficult physical delineation might be, so you may have to rely on logical. This is also apparent when you go into a data center, for example, like a cloud data center. You have a cloud instance, yours is a logically separated cloud from somebody else's, but the underlying hardware that the cloud provider is using, you may be on the same rack of equipment, sharing the same CPUs, RAM, and hard drive space. Once again, you can pay to have your own physical devices, but now the data center and that vendor has to provide that just for you and not be able to use the economies of scale. You're going to pay more. Depending on the type of data you have, the type of contract you have with the DoD, that might be a requirement, or you look at going into something like a Gov Cloud where they've already done that for you. And then understand and implement the compensating controls. In a lot of cases, you're not going to be able to just meet the control outright the way the auditor wants. Maybe you have a business reason why you can't do it, or there's a technical limitation. So if that comes up, one, you're going to have to make the argument as to why you can't meet the control the way it's designed. And two, the first thing they're going to look at is, well, what have you done to compensate for that? So what are the different ways that you can mitigate as much of the risk as possible by not being able to meet the letter of the law, so to speak? And there's a good guide, 800-161 for guidance on system security engineering. Pretty straightforward guide. It'll help you out. I would highly recommend that one. Separating user functionality from system management functionality. This one's pretty straightforward. I think most of us know about this and are already implementing this in our environment. But just to define what they're calling system management functionality, that would be if you want to administer databases, network components, workstations, and servers. So, your normal user should not have an account that's a basic user account that can be hacked, that can then go out and administer anything on the network. Once again, make the separation physical or logical, and then consider a whole bunch of items that maybe you weren't thinking of at the beginning. Do you have different systems? Are there different interfaces, like different NICs, different user accounts, separate virtualization, different authentication methods? The idea behind this is, yes, it's more work for you to implement 2 different types of systems, or the quantities double from the number of systems, But if attacked and someone moves laterally, the amount of damage they can do and how much movement they can make is limited. Just using different authentication methods can do that, because if someone gets past MFA, but you have a separate, different type of authentication method for a different system, they're going to be limited only to where the MFA is being used that they were able to hack. So again, it's more work, it's more thought that has to go into it, potentially more cost, but it's another way to segment what someone can do if trying to escalate privileges. Prevent unauthorized and unintended information transfer via shared system resources. This one's going to be a little bit harder depending on what type of assets you have. Folks, are very familiar with hard disks and information that's stored on hard disks, but making sure that you can clear memory, cache memory. Printers and copiers are a good one that come up all the time. When you're in a classified space, for example, and you have a copier, how do you flush the memory cache on that copier so that you can't go reproduce what someone else had just copied on? So you're going to have to look at your environment, see what type of assets fall into this category, and then see if you have the expertise to manage it, or do you need to reach out? And again, this is one of those areas where we're starting to move into controls that I think third-party support may be a requirement for a lot of folks, especially if you're smaller and new to the space. Implementing subnetworks for publicly accessible systems, whether physical or logically separated from the internal network. The term demilitarized zone, or DMZ, it's one that's been out for years. I don't hear it as often anymore, but that was always that, hey, let me build this little subnet or enclave where something from the internet can access it, but then everything that I don't want you to touch is behind that in my internal network, and it serves as like a gateway or proxy to make requests on behalf of users without letting users go directly to the resource. I think that's still obviously done in a great extent throughout networks. I don't know how many people call them DMZs or build on a network topology diagram. Here's a little fence around my DMZ. I think it's done in other ways, but the concept is still there. So once again, go out, look at the two special pubs that are here for additional guidance on doing it. But this one's a pretty straightforward one as far as subnet and segregate as much as possible. You can do this both from a tenancy space if you're dealing with more than one client or one client's data, and each can have their own tenant space. If you're a developer, look at things like non-prod and prod, and even different levels within non-prod. Each one of those can be a logical separation from another network. Deny network communication traffic by default and allow by exception. This one's really simple. I only have one bullet here. You want to have a deny all and then permit based on a need, because every time you permit, you're poking a hole, let's say, in a firewall. You have to be very careful that the devices that you have implemented don't do the opposite and allow all and then deny by exception. Especially in your lower end equipment, your home office and small business type equipment, a lot of the vendors will start with an allow all because it's plug it in and it immediately works. If you have to go in there and start with a deny all and then configure it to tell you what's acceptable, that's more administrative work. So depending on your application of how you want to use it and where you want to use it and which vendor you go with and what level of equipment, whether it's enterprise or SOHO type equipment, the rule set could be exactly the opposite. Be very careful for that, because again, you don't want to allow by default. Prevent remote devices from simultaneously establishing non-remote connections. So split tunneling is the best example here I can give of this one. And that's really what the intent here is. They want you to prevent a connection from a corporate resource and then also connecting to a non-corporate resource. So my example is you have a work laptop. Let's suppose it's a corporate furnished laptop. You connect to your corporate network via VPN, but then you want to print something. Ideally, if your organization will allow it, you would download the file from your corporate network to that computer, you disconnect from corporate, and then you would connect to the hotel internet or Wi-Fi and then access the printer. But without the proper technical controls in place, there are ways that you could be connected to the corporate environment and then use your laptop as a pass-through to print to the hotel. In doing so, anybody who's then on the hotel network who could potentially access your device then has access to the corporate network. Ton of technology that can be put in place to prevent scenarios like this, but it's the type of thing that you need to be considering and going back and validating, is this set up? Can this occur? Have you blocked it, et cetera? And you want to pay special attention to the fact that not everyone uses corporate furnished, laptops or equipment. What if they're connecting with a phone? What if they have a BYOD device, or simply anything with mobile computing capability? If they can make a connection to data, you have to ensure that that data cannot be funneled off to another network. Cryptography, we're going to get into a few controls here that deal with cryptography, especially as we move more into CUI, but implementing the correct cryptographic mechanisms to prevent unauthorized disclosure of CUI during transmission. This applies to any device that can transmit CUI. So do not limit or put blinders on and you say, well, here's how I want people with our workstations or servers to behave. Do you allow anything else that could potentially see CUI? This is where, again, going back to your telecommunications provider and look at what type of offering they have. Some of them will be fully dedicated. Some are solutions that you can purchase and bolt on to what you already have. But again, for varying price levels and depending on which provider you have, you're going to have options out there to help meet this control. It just, again, may come at a cost. And you're going to see NIST crypto referenced multiple times. This is a very important doc because as most of you have probably already learned and found out through CUI, you have certain FIPS requirements like 140-2, validated devices that you're supposed to use, or validated software, which is different than FIPS 140-2 compliant. So you're going to want to thoroughly read that document to make sure whatever solution you choose will help you pass the audit. It may do all of the cryptographic features and requirements that you have. So from a security perspective, maybe it's sufficient, but you don't want the auditor to come and say you chose something that doesn't meet DoD's intent. Terminate network connections associated with communication sessions. So this one's really just about the inactivity. How are you timing things out and removing the user's access, any connection, any data tied to that connection? And a lot of ways that, if like going to a laptop, for example, you walk away, it locks, great, that's a screen lockout. But what if you're connected when that locks and you're running a job? We see this a lot, or I've seen this a lot in the past in the DoD, when you would run long backup jobs and you need to stay connected, and then DoD's communication session would terminate after, say, 15 minutes of inactivity. Well, you need that connection so that you can run certain jobs for backups, so they would have to tweak the rules. This is the same type of thing that you're going to have to look at. Can you model your work in a way that you don't need to stay connected? You can kick off a job, it can run on that device and you don't need a connection. And if you do you have to modify those timeouts so the sessions don't die due to inactivity? And again, anytime you deviate from what's expected of you, you're going to have to document and be able to defend it. Establish and manage cryptographic keys for cryptography. You're going to have to look at too whether or not a manual process or a solution makes sense. There's going to be tools obviously involved. You're not going to be able to do everything manually, but at what point do you try to automate? What point do you rely more so on tools than process? That's really going to come down to most likely the size of your organization and the budget that you have. But when you're doing it, don't forget that you have to look at any applicable executive orders, laws, policies, directives, regulations, and standards. So again, this kind of goes back to the same thing with the FIPS 140-2 comment. Don't go out necessarily and look for a solution simply because when you read a control, it says, well, I have to manage cryptographic keys. Oh, hey, this cheap solution out there does it for me. It may not meet the requirements based on like 856A or 857.1. Consult those first to make sure there's not something in there they specifically call out. And that way, when you're evaluating your vendors, you can look at them and ask, do you meet these requirements? If not, they should immediately be removed from a list of consideration. And whatever you choose, don't forget or overlook the process of the creation, storage, and disposal. It's one thing to have a solution that can create keys and store keys for you, but someone needs to manage that. There needs to be processes and procedures in place, and you need to be able to provide evidence that you're following them. again, remember, for every control, there's a component that's essentially the security part of it, which is increasing our security posture. And there's the compliance part of proving to an auditor that you're actually using the tools as intended and as you've outlined in your policies and your procedures. And the FIPS one finally came up here, employee FIPS validated cryptography, FIPS 140-2 validated solutions, not compliant. Where you'll see this a lot is Microsoft's a good example. They will tell you on their website that a product or solution is compliant but not validated. Then they'll go on to put a subnote in there to say, we may have combined 4 different solutions. Each of these 4 solutions in of themselves were validated, but the package or suite of package tools together has not been validated. I'm still waiting to hear, I think, like many others, of whether or not the DoD will accept that, or if the new suite or combined package has to be validated. But for now, the rules say they must be validated. So be very careful. This is not a semantics deal. A lot of companies have compliant solutions, but compliant isn't good enough today. Prohibit remote activation of collaborative computing devices and provide indication of devices in use to users. This one's very interesting because, again, if you read this, you may go down one path mentally. If you go look at the NIST documentation, you'll see that they talk about things like whiteboards, cameras, microphones. So they want to know about all of these other peripherals, and you have to know about these other peripherals, and then a mechanism that identifies when a device is in use. So, for example, I know of some vendors whose conference room cameras will, they'll light up with a blue ring around their camera, or they'll go through a process where they pan and tilt as part of like a setup. That at least tells you they're on, and then depending on the color of the ring, it could tell you whether or not it's actually in use. Some devices that may not be that easy. Some of the smart whiteboards may have a little light that indicates it's got power to it, but it doesn't tell you whether or not it's in use, whether it's sharing information, transmitting information, etc. So be very careful that if any of those things are in your environment, you do have a way to indicate when when a device is in use. Use of mobile code. I put some examples up here taken from this, but this one, the biggest thing I can say about mobile code is you're going to be using mobile code. I don't know of anyone that operates without it. You're going to need the support of the business and what the business decision is of why you're using these things, any compensating controls you can put in place, and then wherever possible, do things like making sure the code is digitally signed by a trusted source, and make business decisions like, will you allow this stuff on your servers? Can it be on the server, but it can't be downloaded? Can it be downloaded, but not executed on a workstation? There's a guide, 828, which provides guidance on mobile code, but a lot of this you're going to see as a business decision. I think the business decision needs to occur first because you know what you need for the business to operate. And then you're going to have to sit down and go, now, how do I control this? And what compensating controls do I want to use? I would recommend against going and trying to implement controls if you haven't at least done the business decision-making portion of the process. Voice over IP, there's a big uptick in the fact that you have a lot of transmission speed and bandwidth. The lines are essentially the same as all other traffic. If you're going over Ethernet, like in an office, you're not on a dedicated phone line. So there's going to be new threat vectors that exist. And the fact that it's happening at much greater speeds makes it more difficult to catch and stop and prevent before there's a problem. So treat all VoIP devices just like any other network device. This can be a little more challenging because VoIP is finicky. And once you start putting security controls in place, you may get dropped calls, you may get quality going down, you have quality of service type things that occur. So this is probably going to require some testing, but you must treat the VoIP devices like any other device. Protect authenticity of communication sessions, making sure that you're protecting against man-in-the-middle attacks, especially when MFA is involved, any session hijacking, and the insertion of false information into communication sessions. And one of the things they called out, which I think is important as well to say, is implement controls that protect communications at the session level versus the packet level. Anybody who's dealt with the OSI model and the 7 layers, that there's different layers. certain devices and networking appliances are going to operate at certain levels. Some will be more restrictive than others. If you're operating at layer 7, then you're obviously looking at all layers and you have the most visibility and the most capability for security. If you're only dealing at the packet level, layer 3, it might be faster because you're just dealing with packets and more routing, but there may be less security involved. So look at what your appliances are capable of, look at what you're trying to protect, and make sure that you have the right device and appliance and vendor for what you're trying to implement. It may come down to what you own simply is just not capable of providing something at the session level, in which case you have to consider changing devices. And protect the confidentiality of CUI at rest. Probably one of the easier ones, at least when most people look at this, in that, hey, I'm going to encrypt everything, but consider implementing file share scanning, make sure the files are encrypted and that the encryption requirements are met, not just simply anything that's encrypted with any algorithm. And they did point out one thing which I thought was nice. It said if adequate protection of information at rest cannot be achieved, or continuous monitoring to identify malicious code at rest couldn't be achieved, there are options to use secure offline storage. They will consider that. They did not go into detail of what the requirements were or how that would be evaluated, but at least there are options there that if one is not feasible, you have an alternate path. So it's almost like they're giving you a way to provide those compensating controls. So again, this one's a pretty straightforward one when it comes to most people just immediately thinking file encryption, but think about how and what layer, what algorithm, how secure is it? Does it meet the requirements of the DoD? Again, the last thing you want to do is buy a product, go out and encrypt all your files, and then have to rip that product out of your environment and then you replace it with something else. And that's it. So I will sit here for a second and see if anybody has any questions. I don't see any yet in the Q&A. Otherwise, if you don't have questions, I again appreciate you showing up. Next month, we'll have our last CMMC session, and then we will be off and on to bigger and better topics, hopefully.